Hello everyone, my name is Karish Gupta and today I want to talk a little bit about artificial intelligence. Now artificial intelligence has become something very prevalent in our lives today, and I'm sure all of you have heard of words such as machine learning, deep learning, and neural networks. So today I want to talk a little bit about what those concepts really are and how they affect our daily lives and where we might see them. And then I'm going to do a bit of a demo of an application of AI that I've been working on. So let's start off with the basics of what AI is. So AI can be defined as the simulation of human intelligence by machines. So in other words, they're systems that can reason, learn, and solve certain problems under specific situations. So now experts say that there are three types of artificial intelligence, two of which still don't really exist yet. So the first one is artificial narrow intelligence. You can also call this artificial weak intelligence. So this is where AI is able to complete one task really well. So it might be able to play chess, it might be able to translate language, or vacuum your house. But it can't really do anything else other than that one task. And this is about where our technology is currently at right now. And then there is artificial general intelligence. You might call it strong AI. So this is where artificial intelligence can do almost everything humans can do, just as well. So this is still something very much in sci-fi. We don't really have artificial intelligence that can do about everything that humans can. But you can think of things like C-3PO or droids from Star Wars. Those would be pretty good examples. And then there is artificial superintelligence. Now this is something that's still pretty controversial in the field. Some say it'll come around in 100 years, 500 years, some say it will never come around. But this is when artificial intelligence surpasses human intelligence. They basically become superior in just about every way, shape, and form. And again, this is something that is still very much only in sci-fi. So now let's talk about where we might see artificial intelligence in our daily lives, how it's applied. So I'm sure most of us use autocorrect just about every day. So that is an application of AI. It is a NLP, a natural learning processor. We're going to get into natural learning processors later in the presentation, but just so you know, they are an advanced form of AI that uses neural networks and that is designed for the complexities of language. And then there's facial recognition. This is part of the field of computer vision. So computer vision has become a very prominent field nowadays that combines computer science and robotics, giving robots sensors that allow them to see and sense things just about the same way humans can. So facial recognition is used in iPhones nowadays for Face ID. So that's a good example of a security measure, security application. And then there's self-driving cars. So this is again part of computer vision. So it uses, so this is an example of the Waymo taxi. These have gotten really popular in the West Coast because they're really great for COVID safety. And as you can see, there's a very prominent sensor at the top of the car that gives it a 360-degree view of everything around it. So it can kind of see signs, traffic lights, and obstacles to get people from point A to point B most efficiently. And then there's, I said Google recommendation systems, but really you can say any recommendation systems like the YouTube algorithm, Netflix recommendations, Amazon recommendations. All of these use a machine learning based recommendation system that takes in user history data like media you consume, videos you watch, news articles you read, and based off of that, it will give you suggestions that you might enjoy. And then I said a diagnosis algorithms in healthcare. So healthcare has all kinds of applications of AI going on in it right now. There are all kinds of development happening there. But diagnosis algorithms are a pretty good example because these can basically take in data such as like fracture, x-rays, or spreadsheet data, and it can give you predictions based off of that. So it basically can be used as a second opinion that doctors can use to kind of verify their own predictions. Now let's talk a little bit about machine learning. So machine learning focuses on the use of data and algorithms to imitate the way humans learn by gradually improving the AI model's accuracy. So there's three basic steps. The first is to take data that can be in the form of image data, spreadsheets, voice recordings, or text, and then you build a math model. So this math model can be anything as simple as like linear regression or quadratics or exponentials, and then or it could be something as advanced as like data trees. And then it finally makes a decision or gives some kind of output. So what makes this really special, however, is that it can continue to take in data and continue to get smarter and improve the model's accuracy even after it's built it. So generally there are three types of machine learning. There is supervised machine learning. So supervised machine learning is defined by its use of labeled data sets. So you could say there's a little bit of a supervising or human intervention, because we are basically telling the machine how to categorize things. And then the exact opposite would be unsupervised learning. So in this case, you give the machine data, and then it basically finds whatever patterns in the data it can find, and then it clusters them into groups just based off of whatever it sees. So this can lead to some really interesting findings, because the machine can actually find patterns that us as humans, we legitimately just cannot find. And then finally, there's reinforcement learning. So reinforcement learning, you can think of this as like trial and error, because it uses a reward and punishment system. So it punishes behaviors of the robot that it does not want it to do, and then it rewards behaviors that it does want to do. And it starts off very inexperienced, very inaccurate, and then the model over time, as it gains experience, it actually becomes much more accurate. So now this is where things get a little more complicated. This is neural networks and deep learning. So neural networks, they mimic the human brain through a set of algorithms. So they're essentially just arrays of nodes or neurons that each compute complex math problems to reach a certain threshold, similar to how actual neurons work in the human body. So biologically, neurons use electrochemical signals, and they send them across the axon of the nerve, and then if that electrical signal is above a certain threshold, it gets shot off to the next one, and so on. So this is basically kind of how it works in the computer as well. So what's going on is that instead of having an electrochemical signal, you have input values, you have numbers, right? And instead of sending it physically across an actual neuron, instead you have math problems that's computing in each nerve. And I'm going to show you in each node. And I'm going to show you what a visual of this is actually going to look like. So these are usually comprised of 5 main components. There is inputs, weights, a bias, and a threshold, and an output. So for math people out there, weights are just a multiplier that gets multiplied by all the input values. They're usually noted by the variable w. And then there is a bias. So biases are just a constant that you add to push the computation towards the threshold or away from the threshold if it's a negative number. And neural networks that consist of more than 3 layers are usually considered deep learning algorithms. So you might hear them called deep neural networks or deep learning algorithms. They all really kind of mean the same thing. It all hints towards this kind of structure. So visualize, this is kind of what you're looking at. So you got layers. So this would be the first layer, second layer, third layer, fourth layer. And this is a 5-layer neural network, right? So you have, each of these is a single neuron or a node, and within them you have certain math problems. This is a very simplified version of one that you might see, but each of these might be having something like this going on within it. So it goes from layer to layer. So from the first layer, you're going to have each of these nodes computing something like this, and then they're going to, if the values are above the threshold, it gets shot off to the next layer. They all get shot off to the next, and finally you will get an output that makes some kind of decision. So again, you can see some of the variables that we're talking about. You've got x as your input, you have w as your weights, and then you have a bias being added as a constant. So now we're going to talk a little bit about a application of neural networks, and that would be natural learning processors, or NLPs, as we mentioned earlier. So these are computers with the ability to understand text and spoken word in about the same way us humans can. So they combine linguistics and rule-based modeling of the human language with machine learning models. And this allows machines to interpret text and written word in just about the same way we can. And is used a lot in social media platforms. These things can go as far as understanding the emotion or sentiment behind certain pieces of text. And a lot of social media platforms use sentiment analysis algorithms to figure out if certain posts are offensive or are just not appropriate for what their website wants. And that allows them to get rid of certain posts and take them down. So these use recurrent neural networks. It's basically just a specialized subset of artificial neural networks that are designed for the complexities of language. And some examples of this would be language translators, spam detectors, chatbots, virtual assistants like Siri, Alexa, and Google Home. So now we're going to switch gears a little bit, and we're going to talk about an application AI that I've been working on called Grease. So Grease is a college search chatbot for students looking for information on undergraduate college enrollment. So as a senior that has been through the college search process, I can tell you that it can definitely be very stressful for myself, for all my peers, and especially during the start of the college search process, around the end of junior year. It can be very intimidating to figure out where you should start, what you should ask for, what you need to figure out and find information on. So I thought it'd be really cool to create an application in AI, such as a chatbot, that could even be implemented onto websites like Naviance, Score, or even the College Board website itself, that could actually help students figure out where to start, and it would allow them to ask questions, and then it would respond with small blurbs of information that could give them quick responses, quick information, and it can even give them links to where they need to go. So as of right now, the version that I've created has information on 10 colleges, and it uses machine learning to understand 9 different intents. So an intent is basically a question that you might ask it, a topic that you might have in mind, and there's various different ways that you can ask the same question, right? So you could say hi, hello, hey, what's up? All of those have the same intent for hello, but they're all asked in a different way, and you might call those utterances. So this, again, uses RNN technology to find patterns in text examples to learn many utterances. So again, utterances, all the different ways you can ask a certain question, and then it can continue to train on new utterances. And over time, it can improve. So this has been listed on the pamphlets of that you were all given. So the pamphlets you've been given has all these listed, all the colleges that it has information on, and all the topics you can ask it questions about. And the pamphlet also has a second QR code that you can scan, and it'll take you to a preview API, a preview website that you can basically try it out, test it out, and see if you can find some information that might actually be helpful to you. So now we're gonna do a bit of a demo. I'm gonna show you exactly how this works. So I got it open right here. This is what you'll see once you scan that QR code. It'll take you to this exact same website, and it's going to ask you, hello, my name is Grease. I'm your college undergraduate search tool. How are you? So I am well. How are you? And then it's going to take a second, and it will give you a response. I'm doing quite well. How can I help? All right, so let's say you are looking for information on, I don't know, the tuition of Harvard University, let's say. So, how much is the tuition for Harvard? And again, give it a minute, and there you go. So it gives you a blurb of like a quick response, and then it'll also give you a link that will take you directly to where you want to go. So it's saying the tuition charges for the 2021 to 2022 academic year is $51,904 for full-time students. Room and board is estimated to cost $21,130, and books and supplies are estimated to cost $866, etc., etc. And if you weren't really satisfied with that, you can always hit that link. It'll take you directly to the website, and you can look through all this information and get exactly what you need. So it's basically a quick and simple way to get whatever information you want when you're going through the college search process. So now let's try it again. Let's try what are the application deadlines for WPI? And give it a minute, and there you go. So WPI has 3 application options: early decision, early action, and regular decision, and then it gives you all the deadlines listed right here. Again, hit that link if you want more information, and you can always look for more. There you go. So the real machine learning here is going on in the AI's ability to understand the questions that you're asking it, your intent. So you can ask the same question in a bunch of different ways, but it's been trained on many different examples, and now it's able to understand your intent in even more ways than it's been trained on, because it's able to find these patterns because of the RNN technology that's been put into it. So let's try it out. Let's say I want to see what the UC Berkeley campus looks like. And even if I do make small spelling mistakes, it will be able, or it should be able to still understand what you're saying. And there you go. Okay, so that's what the UC Berkeley campus looks like. We got 2 images, but let's say somebody else asked that same question in a slightly different way, right? So let's say, show me what the UC Berkeley campus, or you know what? Let's just say, show me the UC Berkeley campus. Keep it short, and it's still able to figure out what you want it to do. So now let's make it even more difficult, right? So let's just say, show UC Berkeley campus. And it's able to figure it out. There you go. So again, it uses machine learning to understand all the different ways you might be able to ask that same question. So now let's switch back to the slides, and again, you guys can play around with this all you want. The information is on the pamphlet, so please go try it out for yourself. See if you can find some information that is useful to you. So now I want to end this presentation off with the black box theory. So the black box theory basically says that as AI complexity rises, accuracy improves, and so does ambiguity. So in other words, as our technology advances, as it becomes more complex, it gets smarter, it gets more accurate, but we understand how the logic, how it's getting to its answer less and less. So this brings up the AI conundrum, that the most capable technologies, deep neural networks, offer few clues as to how they arrive at their conclusions. So a really great way to visualize this is through the hypothetical from Dr. Jonathan Mahatny. He brings up the example: what if we made you an artificially intelligent computer model that forecasts real-world events such as political instability, weapon tests, and disease outbreaks, and it predicts that North Korea is getting ready to fire missiles at Alaska? Now, it can be any hypothetical. It doesn't have to be North Korea firing missiles anywhere. It could just be something really bad happening, right? Now, would you use it? Would you go up to the president and tell him, hey, this is gonna happen, I'm 100% sure that this robot is right? Or would you just say that's wrong and pass it off? Well, most experts would ask, well, would I be able to explain the logic behind it? Would I be able to explain how it got to its answer? And the problem is that in a lot of cases, we wouldn't be able to explain it, because machine learning algorithms write a lot of their own code themselves as they learn more. So after a certain level of complexity, it becomes almost impossible for us as people to understand the logic that's going on and the programming behind it. So that's why a new goal that has come up in the field of artificial intelligence is to ensure that we understand our own algorithms. Experts and researchers nowadays are rigorously testing inputs and outputs in their own algorithms, and some people are creating new languages that have more safety checks and security measures to ensure that we understand the logic behind our algorithms. And that's what my goal here was today. It was to give you all a bit of a glimpse on how our own technology is advancing, where we're at right now, so we can all be a bit more aware of our futures and the future of artificial intelligence. Thank you all so much for watching, for tuning in, and for your time. Thank you.